this example here. It says let h of x equal 3 to the x plus 1 minus 2. And k is h inverse of x equal, is x inverse of x. For what values of x does k of x equal 1 for this? So it certainly is an option for this problem for us to go through and find the inverse of this. We could switch our x and y's and solve, and then we're looking for where that equals 1. However, if I've got h inverse of x equals 1, let's use that instead of the k notation there, then that means I've got on h inverse of x, that means I've got the point question mark 1, right? The y coordinate would be 1. Right, because when we plug in an x coordinate, it goes here, and then the answer we get out is our y coordinates. So I've got this point on h inverse. What would that mean for just regular h of x? What point would that be on regular h of x? 1 question mark, right? So to find this value right here, the quickest way to do that is going to be just to plug 1 into the original equation. So if I do h of 1 equals 3 to the 1 plus 1 minus 2, that's going to be 3 squared minus 2, which is 9 minus 2, which will give us 7. So, that 7 right there is our y coordinate here for h. That means it would be the x coordinate over here for the inverse. So this would be x equals 7 for that. Okay. Let me look. The inequalities are something new. I'm gonna pull up the key for the. Oh wait. Part 2 key. I gotta go over here for it. Just to make sure, coming off the spring break, I don't teach you guys something wrong. The inequalities are not something we used to do in this, so let me pull this up and make sure I'm doing it right. I don't know why I put that as example 2. But it's fine. It's fine. We can do that. Okay. All right. So, for example 2, it's a similar type question. This one has nothing to do with inverses, though. It doesn't tell us anything. They did call it K, which is a little confusing, but this is a separate problem. You know, we don't have the same numbers here. They give us what K is. So, K this time is not an inverse at all. They are wanting to know all the values where K of X is less than or equal to negative 31. So for this, we're just going to take our equation, 1 minus 4 times 2, x minus 3, and we're going to set it less than or equal to negative 31. And what we'll do here is we're just going to solve this equation. For this, it's not, actually, we're going to solve this inequality. It is not an equation because we don't have an equal sign. But we're going to solve it like it's an equation until we get to something that would cause us to have to do something different. That there's several things that could be, but the main thing is if like we divide by a negative, we've got to flip that inequality sign for that. So what should I do first? I'm trying to get that x right there by itself. Subtract that 1. So I'll have negative 4 times 2 to the x minus 3 is less than or equal to negative 32. Okay, what would I do next? Divide that negative 4. So that is going to give me 2 to the x minus 3 is less than or equal to, oh wait, hold on. I just divided by a negative. So I just warned us of this and then messed it up. We got to flip that inequality sign because we divided by a negative. So it'll be greater than or equal to positive 8. Now, I could, would it be okay to do that? I got a couple options here. I think it's going to be okay either way that I do this. I'm going to show you 2 different ways you can solve from here. This would be given to you without a calculator, though. So that is one reason I kind of hesitate here on which way would be the best. So if I'm trying to solve now, I need to get rid of that 2. How do I get rid of a 2? Log base 2. So I will log base 2 this and log base 2 this. I will have x minus 3 is greater than or equal to log base 2 of 8. And then I will need to add the 3 over. So x will be greater than or equal to 3 plus log base 2 of 8. However, they will not give this answer like you see it here. It's going to be a whole number. Because log base 2 of 8 can be evaluated. Log base 2 of 8. What would that be? It's going to be 3. Because that could be log base 2 of 2 to the 3rd. Those cancel. So this is really just x is greater than or equal to 3 plus 3. So x is greater than or equal to 6 for that. Let me show you another option on this one that I think is a little bit easier if you think about doing it. Now, I would only do this if you can get the bases to be the same. But 8, I've got 2 to the x minus 3. 8 can be written as 2 to a power. So if that was a 9, this method would not work on this problem. You would just solve it like we did over on the left. But I could write this as 2 to the x minus 3 is greater than or equal to 2 to the 3rd power. And now, because my bases are the same on both sides, like if I do log base 2 of this side, it cancels, and log base 2 of this side, it cancels, I just get x minus 3 is greater than or equal to 3, and then I add 3 right here. So x is greater than or equal to 6 for that. That is only an option because I can rewrite those with the same bases. If you can't rewrite them with the same bases, you've got to do it like we did over here on the left. I think if you recognize it, this is a little bit easier because you don't have to deal with that log base 2 of 8. But this is how I would probably solve it if I did not recognize that could be written as the base. Okay, questions there? All right, let's move on. All right, so it says here, previously we solved inequalities of polynomial and rational functions. To do this, we first found any x-coordinates where the functions had zeros, holes, or vertical asymptotes. Then we used the sign chart to determine intervals where the function was positive and negative. We can solve inequalities involving exponentials and logarithms in the same way, except it's much simpler when working with exponentials and logs, believe it or not. Here, so let's look at what we're dealing with here, and it's been since before break since I looked at these inequalities, and let me just remind myself here. Okay, yeah, I remember now. All right. Okay. So, we're looking for where this function is greater than 0. So we're going to start off just by doing log of x squared minus 4x plus 7 minus log of x plus 3 is greater than 0. Now, one thing, if this was an equation, I would move one of these logs to the other side and I would drop the logs. You can't really do that when you have an inequality sign. That dropping the logs could create an issue if you have an inequality sign. So I'm going to have to solve this without dropping the logs on both sides. So with these, you want to, oh wait, I'm forgetting something here. All right, so first of all, it says determine the domain of any log expressions in the inequality. So logs, whenever we're dealing with logs, we cannot take the log of 0 or a negative number. So that means what's on the inside of this right here has to be greater than or equal to 0. Oh no, actually just greater than, cannot equal 0. So x squared minus 4x plus 7 must be greater than 0. It's also true that x plus 3 must be greater than 0. Now, this one is easy. X plus 3 greater than 0. That's just x has to be greater than negative 3. If we get any answers below negative 3, we can't use them because they're going to give us 0 or a negative here. So that's a restriction on our domain. Over here, flip over to the key on this really quickly. Why don't they worry about this one? I don't know why he doesn't worry about that one. I mean, I know why I don't want to worry about that one. And that is because that would be complicated. And it doesn't factor. So you'd have to use quadratic formula and make a chart. And he didn't do that. Let me look one more time. Why does he only think about that one? Let's see, negative 3 squared. Okay, I think this is why he does not think about that one. Definitely, this one is easier to think about. So we're already restricting this to negative numbers. I think what he's thinking about here is like if I plug in negative 3 squared minus 4 times negative 3 plus 7. That's going to give me 9 plus 12 plus 7, which is in fact greater than 0, right? And any negative number I try is going to do that. Positive numbers, even if I plug in 1 or 2 or 3, I'm going to get positives for everywhere in that domain. So I think that's why he does not worry about that first one there. Although technically we could look at it, but it's going to take us a lot of time. So the x greater than negative 3 covers this one as well. So it would have some values that might make it, I don't know if it would actually have any values that make it negative. It actually might be positive everywhere. So I think you just sort of reasoned through that maybe. So the next thing that we want to do, now this is just a restriction. So we know that like nothing can be below -3 on this or it will make that false. So now we're going to actually solve. And so we are going to combine any logarithms that can be combined. And so if I have subtraction with logarithms, what does that become whenever I put those together? Division. So this will be log of x squared minus 4x plus 7 over x plus 3 is greater than 0. And I want to get rid of that log. What's the base on that log? It's 10. So I need to do 10 to the power over here and 10 to the power over here. So that will give me x squared minus 4x plus 7 over x plus 3. And here's why that becomes helpful. 10 to the 0 power is 1. And anything to the 0 power is going to be 1. So that works out nicely for us. We need to solve this equation. We cannot solve this equation when we have x's in the denominator. I keep calling it equation. It's inequality. So I would need to multiply by x plus 3 over here and x plus 3 over here. So I will get x squared minus 4x plus 7 is greater than x plus 3. That you're not going to be able to figure out. This is a quadratic. You would move everything to one side. So you would subtract that x and subtract that 3. So we got x squared minus 5x plus 4 is greater than 0. Now, this is polynomial stuff that we did at the beginning, and this is where we would like factor it, find all those zeros, and make that sign chart there. So this will factor. We'll have x and x. We're going to have a minus 4 and a minus 1. And so the zeros that go with that would be x equals 4 and x equals 1. Now, we need to test this in a sign chart. And I've got 1 and 4 that need to go on this. There's also another number that needs to go on here, and that's -3. We're not going to put anything below -3, right? Because that is our restriction for our domain. So then we've got our 1 and our 4. And our only two values here are x minus 4 and x minus 1. You can use that most simple part that you have at the end. X minus 4, x minus 1, and your answer. You guys remember doing this long, long ago. So that negative, the x minus 4, it's going to be negative for those first two, but positive when you put in a number bigger than 4. And the x minus 1 is going to be negative, positive, positive. If you plug anything any bigger than 1, you'll get a positive number. And then so that gives us our answer is going to be positive, negative, positive. This is looking for greater than 0, so is that the positives or the negatives? Positives. And that is going to be 1 to 4. Or it may be written like this, 1 is less than x less than 4 for that. Oh, wait. Those are the wrong answers. What am I thinking? That would be if it was negatives. It should be negative. Negative 3 to 1. Sorry about that. Negative 3 to 1 and 4 to infinity. Or you might see that written as negative 3 less than x less than 1 and x is greater than 4. So it could be this one or this. the reason that he says this is easier than the polynomials. That could be debatable there, but is because this is usually going to just become a quadratic right here, or maybe even more simple than a quadratic. So you won't have to factor out anything much longer than that. Okay, questions? All right, let's look at the next one. Let me make real quick. No, wrong thing. Yeah, everything on one side. Make sure. All right, so for this one, they give you two inequalities, and they're asking you which values g of x is less than h of x. So we're going to take g of x, which is natural log of x squared plus x minus 5, and it's got to be less than h of x, which is natural log of x plus 4. And really, before we even do this, I should have thought about that domain first. So this right here, x squared plus x minus 5, has to be greater than 0. And this right here, x plus 4, has to be greater than 0. So right here, x must be greater than negative 4. That's a much easier one to solve. I think, let's look back over here. Okay, this time he does think about this. I really think he might should have done it on the last problem too, to be for sure. But this right here has to be greater than 0. And x squared plus x minus 5 will not factor. So if it will not factor, you're going to have to use quadratic formula. So quadratic formula is x equals negative b plus or minus square root b squared minus 4ac all over 2a. And for this one, that would be negative 1 plus or minus square root 1 squared minus 4 times 1 times negative 5 all over 2 times 1 there. So we're going to get negative 1 plus or minus. That's going to be 1 plus 20, so 21 all over 2. And he did go ahead and just use his calculator to get a decimal there, because it's hard to tell what it would be without that. So we're going to do the same. Oops, wrong thing. Actually, I need that for third period. Nope, that's it. Alright, so if I type in negative 1 plus the square root of 21, oops, divide that by 2, I will get 1.7912. And if I type in negative 1 minus square root of 21, divided by 2, I will get negative 2.791. And so we really need to kind of think about a sign line for this. Just for this, we haven't even started solving the problem yet, which is why this one was so bad. Because this won't factor, I wouldn't do a sign chart for it. I would just go plug back into the original. So if I've got like negative 2.791, I want to pick a number smaller than that, so probably like negative 3. And if I type in negative 3 squared plus negative 3 minus 5, I will get 1, which is a positive number, which is what we want. We want that to be greater than 0. And then if I pick a number between negative 2.791 and 1.7912, that, like, 0 is the easiest thing to use there. If you plug in 0, 0 squared plus 0 minus 5, it's going to give you negative 5. You get a negative in that middle part. And if you plug in a number bigger than 1.7912, like 2 squared plus 2 minus 5, it's going to also give you 1. That's going to be positive right there. So this middle part right here, from negative 2.791 to 1.7912, is not part of your domain, right? So, like, beginning, we're going to have to solve this. We haven't even really started solving the equation yet. This is just our domain. But when we start to do a sign line, we know that we can't have anything below negative 4. And then between negative 2.791 and 1.7912, we can't have anything there either. So before we even start a sign line, we would know that this part right here is off limits and this piece right here is off limits, which it probably is going to end up being factored into our answer as well. So that's not even solving the equation. That is just looking at your domain for that. I really think he probably should have done that on the last problem, but it didn't affect the answer, whereas on this one it does affect your answer. It's probably why he left it off, but he probably should have done this as well to make sure it did not affect the answer. Actually, if we go back up here real quick, let me just show you, I think, why this happens. So let me still use that different color. If I do x squared minus 4x plus 7 is greater than 0, if I use quadratic formula on that, I'll have 4 plus or minus square root 4. Technically, it's a negative 4 squared, but when you square it, it's positive, so I'm just going to do 4 squared minus 4 times 1 times 7 all over 2 times 1. And so that's going to be 4 plus or minus. Here, I'm going to get 16 minus 28, right? So 16 minus 28 over 2, 4 plus or minus. This is going to be the square root of negative 12 over 2. Can you take the square root of a negative number? You cannot. So that's imaginary. And so since it's imaginary, there's no numbers that will make this 0. So you don't have to go any further with that. Everything's going to be positive there, and it does not affect your domain for that. Does that make sense? That. All right, so let's now solve this. With inequalities, you can't just drop the logarithms. That can, what can you? Let me look over. He does not drop the logarithms. However, if we look real quick at what he has done here, so he moved everything to one side. He made it division. He did e to the power on both sides. It gave him a 1. And then he multiplied that x plus 4 times that 1 which is the exact same thing as dropping the logs. And I think that's going to happen every single time. Pretty sure it actually happens every single time. So, alright, unless I find out differently, and I don't think I will, we could just go ahead and do e to the power right here. We will get x squared plus x minus 5 is less than x plus 4. There. Just drop the logs on both sides. And then we can subtract x and subtract 4. So x squared minus 9 is less than 0. And so x squared minus 9 will factor. It's a difference of squares. It is x plus 3 times x minus 3. And so that's going to be a negative 3 and a positive 3. So our negative 3 would fall right here. Our positive 3 is up here. We've got x plus 3, x minus 3, and our answer. And we're also going to include those, well, here's what we're going to do. I'm going to mark out the parts that can't be part of our answers. So we already decided for our domain, like we can't have anything here. We also can't have anything here. So even though it might make this true, we have to throw that part out on our answer. But then we can go through the rest of the chart like we normally would. So if I plug in a negative 3.5, that'd give me a negative here. Something bigger than negative 3, not much, but like negative 2.9. Negative 2.9 would give me a positive here. And then anything else bigger than 3 is going to give me a positive over here. But I don't want to include that negative 2.791 to the 1.7912 because it's not in our domain. And then for that negative 3, we'll get a negative here, a negative here, a negative here, all the way up until numbers bigger than 3, so that would be here. And so this will be positive, negative, negative, positive there. And we are looking for the positive answers because this is greater than 0. So right here and right here for that. And so our answer, we would say, is negative 4 to negative 3 and 3 to infinity. Or you might see it written negative 4 less than x less than negative 3, and x is greater than 3. So either this or this would be our answer. Okay, questions? Okay, so these are just a couple of examples of something that are like practice AP problems, because it says on the AP PreCal exam, FRQ number 4 is going to require students to solve various log and exponential functions using without using a calculator. This is a part of the directions you'll see. So on the AP exam, here's what they're going to require on that free response question as far as simplifying logs. So no calculators allowed. Determine the exact value of any expression that can be obtained without a calculator. So for example, like we just saw on that problem that we solved up here, this one right here, If I have something like log base 2 of 8, it has to be simplified as 3. I can't leave it as log base 2 of 8. You also need to combine terms using algebraic methods and rules for exponents. So where applicable, things like 2x plus 3x, you can't leave it like that. It's got to be 5x. 5 squared times 5 to the third can't be left like that. It's got to be 5 to the 5th power. X to the 5th over x squared cannot be left like that. It's going to be x to the 3rd power. And natural log of 3 plus natural log of 5 should not be left like that. It would be natural log of 3 times 5, which would be natural log of 15. Okay, so this one is the solving equations, and these rules for simplifying apply. It says f of x equals this. We're going to solve f of x equals e to the 1/2 for values of x in the domain of f. So they didn't set this up like an equation, but they say solve f of x equals e to the 1/2. F of x is this stuff right here. So we are going to have to take e to the x to the 5th power over e to the 1/4 equals e to the 1/2. Okay, what would you guys do first on this one? That's probably what I would do. There's other ways you could go about it, but that's probably what I would do. It doesn't have an x, so you're not solving for that, but it's still a denominator that's overcomplicating this. So I would multiply by e to the 1/4 here, and e to the 1/4 here. And so now I will have e to the x to the 5th power equals, what's that going to be? Not e to the 1/8. If I have like x squared times x to the 3rd, what does that equal? X to the 5th. What did I do with the exponents? Added them. So I've got to do 1/2 plus 1/4, which is going to be 3/4. Whenever I do that, you got to get common denominators there, so you multiply by 2 here and 2 here. 2/4 plus 1/4 will give you 3/4. So e to the 3/4. Now, here, when I have powers to powers, what can I do with those exponents? Like when I have multiplying, perfect. X squared to the 3rd, that'd be x to the 6th. I'd multiply those. So I'm going to write this as e to the 5x equals e to the 3/4. And now, since I've got e's on both sides and everything's simplified, I could do natural log of both sides that is going to cancel both of those e's out. I've just got 5x equals 3/4. I could divide by 5 here. What I'm going to do instead, since I've got a fraction on the other side, is I'm going to multiply by 1/5. It is the same as dividing by 5. It'll cancel this 5 out over here, and I will get 3/20 for that. So x is going to equal 3/20. Okay, questions there? All right, let's try this last one. So same deal right here. I'm going to have 8e to the 3x minus e equals 3e here. what would you guys do first? Add that e. So I've got 8e to the 3x equals 4e. What now? Divide by 8. Very good. Sure would be nice if that went evenly, but it does not. So this is going to be, you can either write it as e divided by 2, or you could write it as 1/2 e. I think I don't like either one of them, but I'm gonna do this, I think. I might need to glance over here at how he leaves this answer. Where even is this one? Oh, it's on a separate part. He had like 3 parts of these notes. Okay. What should I do next? Natural log. Because we're trying to get to that x right there. So we need to get rid of this e. Now, what I'm going to have is 3x equals natural log of 1/2 e. Natural log of 1/2 e. Do the e's cancel on that? I'd be leaning towards a no, since Ms. Hyatt wrote it like this and didn't cancel them. The e is not next to that 1/2. So those two things, right, and even if you rewrote it the other way, they still would not cancel because you're doing natural log of that whole expression. So the last thing you need to do is just divide by 3 right here. So x is going to equal natural log of 1/2 e over 3. Now technically this is solved. On the quiz that you guys are going to take tomorrow, you can type this stuff into your calculator. You're going to get a decimal, and you're going to type that decimal in. So it would be okay to leave it here. But if it is that 4th FRQ question, and you're having to do this, it's not simplified far enough here. Because natural log of 1/2 e will break up into 2 things that are multiplied. So we could do natural log of 1/2 plus natural log of e over 3. What is natural log of e? They cancel, but this has an exponent of 1 right here. So when they cancel, you get a plus 1 over here. And natural log of 1/2 is division. So we could break it up with natural log of 1 minus natural log of 2. What is natural log of 2? I'm sorry, natural log of 1. It's 0. Anything right there is 0, so I'll get 0 minus natural log of 2 plus 1 over 3. He writes the answer as 1 minus natural log of 2 over 3. If you had that negative natural log of 2 plus 1, that'd be okay as well. For that. To me, I don't think this is a terribly difficult problem if it's calculator active and you can just type in the answer. I don't think it's as bad if it is multiple choice where you can see your answer is there and kind of work to get towards it. But you do have to know to simplify like this. Basically, you don't want to leave any multiplication or division inside of a log if it will break up for that. Okay, so